Hello, this is question 5.1.75. That is chapter 5, fourth section. For the function f, use the composition of the function to show f inverse is as given. So f of x equal to 19 minus x over x. F inverse of x is 19 over x plus 1. Sometimes we ask you to find the inverse, right? So you know how to find the inverse. But this time it asks you to prove their inverse each other. So in order to prove their inverse each other, you have to do two steps. Step one, you using the original function as the outer composite the inverse function. This is equal to x. And the opposite is also the same. If I put an inverse function in the front composite the original function, this also has to be equal to x. So we can go ahead and prove the step one first. F composite the inverse. According to the definition, F is the outer, the inverse is the inner, right? So I'm going to plug F inverse of x equal to 19 over x plus 1 into the equation in here. All right. So now we back to the f function. So my f function here, okay, so my f function is equal to 19 minus x over x. But remember, this x can be replaced anything by the parentheses. So I can have f of the star is equal to 19 minus a star over a star, right? So this star here is 19 over x plus 1. So when I replace it into the function f in here, I will have a 19 minus the star over the star here. And this star here is 19 over x plus 1, 19 over x plus 1. So we're going to just go ahead and simplify. So now I use the f function for this one. The rest is just a little bit simplified in here. So in order to simplify this one right here, I am going to just multiply top and down. We're going to multiply x plus 1 over x plus 1, make it easier for this one to simplify, right? So if I multiply this one in, I will have a 19 times x plus 1 minus 19 times 19 over x plus 1, and this x plus 1 will cancel out, right? And the denominator x plus 1 and x plus 1 cancel out, so this will be just 19, all right? And then we multiply this one in, so we have a 19x plus 19 minus 19 over 19, and these two cancel out. So the final answer, it is equal to x. All right, so we prove the first one right here. And we're going to do the similar step to prove the second one. If I put an inverse in the front compared to the original one, this is also equal to x. Okay, so second step, we have a f inverse composite f. We're going to prove this is also equal to x, but we're going to go ahead and do the calculation. So this time, this is the outer, f of x is the inner function in here, all right? And f of the x is equal to, we have this f of x is 19 minus x over x. 19 minus x over x. And then if we look at the f inverse function earlier, okay, so the f inverse function here is 19 over x plus 1. All right, so remember this x can be replaced by anything, right? So I can put it a star in here. So this will be 19 over a star plus 1 right here. And this time, this whole thing is the star, okay? So I have a, if I use the f function, I will have a 19, okay, over the star here. And the star here is the parenthesis 19 minus x over x. All right, so I use this one for this function in here. And the rest of this is just simplify a little bit math calculation, right? This is a complicated fraction, okay? The complicated fraction, I will have to go to simplify this one right here. So I have a 19 over 19 minus x over x plus 1. And the quick and easy one to simplify this one here is by multiply top and down by x over x. This is kind of similar like a multiply by 1, right? Everything times 1 still equal to itself. But if I multiply this one in here, I will have 19 times x, 19x. X times the fourth fraction, I will have a 19 minus x. X and x cancel out. And then this one, you will also have to times x in here. All right? So we have a 19x over 19. These two cancel out. So the answer here is equal to x. All right? So we prove these two composition, we prove these two. So therefore, we can say these two are inverse each other in here. All right? So that is the step we can look at that in this case. If you look at the calculator, I'm going to show you a little bit calculator here. If I plug these two functions into the calculator, it will show, so this one is 19 minus x over x. Okay, and then if I graph this one right here, all right, so that is the original one. And then if I graph the second one right here, which is 19 over x plus 1. All right, and you can see these two is kind of symmetry. It's kind of a little bit hard to see in here, but if I graph y equal to x in here, they're supposed to symmetry around y equal to x. So that's why if you can prove these two composition equal to x, they are inverse each other. Okay, that is the concept in here. So we just need to use the composition of the function to show these two are inverse each other, as long as you put the first one composite with the second one equal to x, or the second one composite the original one is also equal to x, and which we just go through the calculation and we prove they both are equal to x. So that is done in here. All right, so hopefully that helped.